Hi everyone. So in this video, a very important discussion. So we are going to do. So what is that? What is the difference between a big O notation as well as a tilde notation we are using? So what is the difference between big O? So when we use a big O notation versus when we use a tilde notation, tilde notation. When we can go with the big O and when we can go with the tilde. So normally, so according to our algorithms knowledge, DSA knowledge, why do we use notations means what? For two things. Big O notation, tilde notation and all. For time complexity as well as for space complexity. What is the purpose of using notations? Only two things. That running time complexity and so space complexity. For using these things only we are using. As we know that, right? How fast they are running and how much memory they are using. What? Like algorithms. Got it? Right. And here, what is a big O notation? What is a big O notation? So what it will represents? That we already know. So first of all, it tells us the worst case, worst case growth order it will tell. Worst case growth order. If you see the example, you will get clarity. Sir, what is that worst case growth order? And one more thing, it will ignore, it will ignore the constant factors. Constant factors means what? Constant factors and lower terms also. Both it will ignore. So what is that constant factor? And so what is that lower term actually? If you see one example, easily you will understand. Let's say I'm taking f of n. Suppose one algorithm is doing that functioning. Let's say 3n square plus 5n plus 2. Let's say consider. Got it? So this is what an exact steps. So whenever n is growing large, n value increasing, n value increasing, n value increasing. Whenever n grows, so very simple, n square is always dominates. N square is always dominates n. This is called lower term, then constant factor. See here, suppose if n value 2, if n value 2 here, it affects this one also. And this one also affects because a very less. Suppose if you take n value is 100, compared to this n square, 100 square, right here it is a 5 into n is negligible. Is a negligible. So no need to consider that. So that's why in big O notation, we always take only the growth order, right? We never consider the lower terms, that is n, as well as the constant factors also. We consider only this growth order only we consider. Okay. So just we drop that constants. So simply we can specify, here it is. So what is that big O notation? Simply order of n square. We just write like this. Of course, order of 3n square. So simply we are writing f of n is equal to 3n square we are writing. We always drop that constant factors as well as lower terms. Hope you got it. So, but in the tilde notation. So what is that tilde notation? Okay, now we consider tilde notation. What is that representing? So this is what more precise approximation of the running time. More precise, clear explanation. Approximately, you have to tell. So we are not ignoring, right? It keeps the leading term with its constant, but lower order terms somewhere it will ignore. How? How? For the big O notation, we are just writing in the 3n square clearly, simply. It is also same ignoring. In a big O notation, big O, it is also ignore that lower terms and constants. Let's say that function f of n equals to 3n square plus 5n plus 2 consider, or 2n square plus 5n, anything. Here in big O notation, we are just taking only n square. But in tilde notation, we consider 3 also, 3n square, right? It will take this term also. That is, okay, leading term with its constant also it will take. And of course, here also we ignoring that lower order terms only. So this one it will take. But in big O notation, 3 will not take, only just n square. And this is what 3n square will take. So this is what tilde notation. Got it? Everywhere, let's say for example, here it is, f of n is equal to, is taking like a 7n log n plus, let's say 20n we are taking. 20n. If it is a big O notation, simply we are writing that n log n. That 7 we never consider. But here it is, we consider that 7 also. The tilde notation, 7n log n we are taking. That's the difference. Just it will take that highest term with its constant. Leading term with its a constant we are taking. Okay, that is what tilde notation. Simply to say, so normally just in real world how we are considering and all. Just general example, a car speed is just we just make it round, is 100 kilometers per hour. 100 kilometers per hour. But if in case if it is a tilde notation, a car speed is 120 kilometers per hour. 120 kilometers per hour. More exact. This is like we just say that is a order of hundreds simply. In hundreds we are telling. Okay, but this one is not just saying like in hundreds, in thousands, in tens, in lakhs. No. Right? So just clearly telling that much more exact. Much more exact. Is 140, is a 120, is a 130. So that is simply called tilde notation. So for example, can you explain with any simple example? See, look at this. I'm writing a code like sum of first n numbers. I'm writing sum of first n numbers. Okay. Here what we are doing, just a sum of first numbers logic I'm writing. Simply in the main, so whatever it is, Java or C. Taking the n value, let's say 5, directly I'm taking. And we are finding the sum. And we know already, repeating the loop, how many times? N times I'm repeating. N times. And every time, just we are doing that sum is equal to sum plus I. Sum plus I. And just here it is a printf. As a sum is equal to percentage D. Let's say that sum we are printing. According to big O notation, right? Each statement, each statement will take a constant time in time complexity. Constant time it will take. If it is a statement, each statement will take constant time. So what is that constant time? We can say that order of 1, according to our knowledge. Now here it is, whenever you are finding the sum of first n numbers, according to big O notation, just that loop is repeating, n times. Loop repeats n times. And simply big O notation is saying that order of n. Like big O of n, simply to say. Big O of n. But if it is a tilde notation, in n times repetitions, what are the statements repeatedly is executing n terms? It clearly explains. Every time sum is equals to n times 3 statements executing. Sum is equals to sum plus I. After that, increasing the I value every time, checking that condition every time. But this is a only one time initialization. N times repeatedly executing sum is equal to sum plus I plus plus, I less than or equal to n. Total 3 statements. Total 3 statements repeating n times. Repeating n times. So simply total operations. Total operations are simply to say constant into n terms. Into n. Let's say C is 3. Adding, incrementing, comparison. Yes or no? This is add. This is increment. And this is compare. This is compare. So simply to say, so what is the tilde notation? What is the tilde notation? It's not n, it's a 3n. Big O notation is a big O of n. Tilde notation is what? Tilde of 3n. Tilde of 3n. That is just that constant representation we are writing clearly. Hope you got it. Okay, na? Right. Same everything. Every loop we are representing like this only. Let's say, for example, linear search. We are taking that linear search because every time we are dividing. Every time we are dividing that login. Let's say we are taking one while loop every time by reducing by half. Let's say here, for example, 32. After that I'm printing 16. After that I'm printing 8. After that I'm printing 4, printing 2, printing 1. Until it is a 1 we are printing, let's say consider. Or up to 2 we are printing. Normally how to write the code? Just I'm writing the code in the main. Taking that n is equal to. So 32 we are taking. What is a loop? Until n greater than 1. Until n greater than 1. Every time we just make n is equal to n by 2, make it half, and we are printing that. Print that n value. Yes or no? It's the same. How many times it is repeating? We already know whenever we are reducing by half, it's a log n times. Log n. Okay. Like 128, if you take, is become 64, become 32, become 16, become 8, become 4, become 2, and become 1. So here it is, you will get 1 with 7 iterations. When n is equals to, let's say, 128, log n means log 128 is equal to 7. Of course, base 2. Base 2. 128 is a 7. Is nothing but log n times simply log n base 2. This is normally, we call it as a binary search time complexity. Binary search time complexity is a 1. So according to this one also, according to big O notation, we just call it as a log n times. But here it is repeating log n times, but every time is making half and printing, making half, printing, making half and printing. So two statements are executing continuously. So is a tilde notation, is a tilde notation, 2 log n it is saying. Of course, base 2. Okay. So this is what it is, also removing the extra constant terms as well as like remaining terms also. But where is the leading term? Leading term constant also it always consider. That is the only difference between a big O notation as well as a tilde notation. Big O as well as tilde notation. Hope you understood.